Okay, finally, we're getting to the last section in chapter 2, which is graphing linear and absolute value inequalities. And so remember that a linear inequality is like a linear equation, but it uses an inequality sign, which means that it's less than or greater than. And so that means that you have to shade the graph. It's more than just a line. And so I hate to do this, but I'm doing it anyway because some people say they forget. But remember that this is less than. I always say if you can't remember, it kind of looks like a sideways L, right? Like L. This does not look like an L. This is greater than. And these two are less than or equal to, greater than or equal to. So depending on what you do here, right? If it's these two when you graph, these will be a dotted line because it doesn't include the line itself. But if it has a line underneath it, when you graph, this is a solid line. Solid, I almost wrote. So when you graph any equation, remember that you have to put it in slope-intercept form. So I gave you some steps here if you're a step person. When you graph a linear equation, you have to, step 1, put it in slope-intercept form. 2, start with your y-intercept to graph. And then from that point, graph your slope, rise over run. And then because it's an inequality, we add these 2 extra steps. Is it dotted or solid? And to shade it. So number 1 here, these are not going to all be in slope-intercept form. So I have to, before I can graph, put it in slope-intercept form, which means I need to put it in this form, get y by itself. So I'm going to subtract x over, and when I do that, I get negative 2y is less than negative x plus 4, or 4 minus x. And then to undo multiplying by negative 2, I'm going to divide by negative 2. But remember, when you divide by a negative in an inequality, that's going to flip that sign and make it greater than. And then I'm going to leave this, a negative over a negative is a positive, but that's going to change that to, right, there's a 1 there. So that's 1/2 x, and 4 divided by negative 2 is negative 2. So step 1, you have to solve it for y. Now I'm going to graph it. So from graphing it, mx plus b, you're going to start with your b, that's your y-intercept. So on my y-axis, I'm going to go to negative 2, and then I'm going to graph my slope. From that point, I'm going to do rise 1, run 2, a slope of 1/2, up 1 over 2, up 1 over 2, right? And you really only need about 3 points probably. Step 4, dotted or solid. And if you forget, you can always go back and just write dotted next to it. But because this doesn't have a line underneath it, this should be a dotted line. Right? And then I'm going to go this way, and this would also be dotted back here. If you have an eraser and you do solid, you can always go back and erase some, right? That's totally not a straight line, but let's pretend it is. If I go down 1, back 2, down 1, back 2. Gosh, I was so bad at that. All right. So that's my line. But it's not just that line. It's everything greater than that line. So I have to shade. Or maybe you remember, less than you shade below, usually greater than you shade above. Why does that work? Because if you pick a point, like if I pick 0, 0 on this graph, if I'm shading above here, all these points would work. So think about if you plug 0, 0, either into this equation or this equation. Is it true? 0 minus 0 is less than 4. That is true. So I'm going to shade above this graph. You check the point, or usually less than you shade below, greater than you shade above. So let's do another one. Step 1, we have to put this in slope-intercept form, which is why in chapter 1 we solved for variables. You have to be able to solve for y. So step 1, I'm going to add or subtract anything that's over here. Keeping track of what's left, this went away. My sign stays the same, and I always like my x first, so that becomes negative 2x plus 10, because that's my mx plus b. And then my last step is to undo multiplying by 5 by dividing by 5. And don't freak out that this is a fraction, because remember it's your slope, and you want your slope to be a fraction. And 10 divided by 5 is 2. So step 1 is you have to get this equation. If you don't get this equation, everything else is going to be wrong. So my y-intercept now is the one without an x up here at 2. And my slope is negative 2/5. So if I go up 2, I need to go back 5. Or if I go down 2, that's my negative, and then I would go over 5. And let's say I forget, right? Let's say I do this. And this is wrong because it should be a dotted line. You can, if you used pencil, you can go back and erase, right? And make it dotted. Or if you don't have a good eraser, or if you have pen, you can always write out here next to it, dotted, like if you messed up. Just write dotted line that I can see it, and then I'll know that you meant dotted. All right? This one is greater than, which means I'm pretty sure we're going to shade above here. But if you're not sure, pick a point. I always pick 0, 0 if I can. So if I plug 0 in here for both y and x, negative 2/5 times 0 is 0 plus 2. 0 is bigger than 2. That is not true. So 0, 0 did not work, so I shade on the other side. So that's how you know how to shade. But again, greater than, we shaded above. The other thing we want to be able to do is graph absolute value functions. And so it's an inequality, which means we're just going to shade. But step one is we want to graph it just like we did before. And if you think about what I said before about how to graph these, or if you think about the transformations that we've done, this is the normal graph, and then minus 2 means it's moved down 2, right? Or if you think about picking 0, 0 minus 2 is negative 2, and it can be negative because it's out here. So 0, negative 2. And then if I plug 1 in there, 1 minus 2 is negative 1. And if I plug negative 1 in there, the absolute value is still 1 minus 2. It's still negative 1. Or if you think about that parent function, we just took that whole graph and we moved it down 2 units. And this one is a solid line because of this. So I'm just going to connect this. Right? But we also have to shade. And so this is where, I don't know, do I shade inside the V or outside the V? I'm going to pick 0, 0 to check. If this works, I'm going to shade inside. If it doesn't work, I'm going to shade outside. So if I plug in 0 for X and 0 for Y, is 0 bigger than negative 2? Yes, so 0, 0 worked. So this means I'm going to shade inside, and I'm going to get creative here. And I'm going to shade everywhere inside this graph. Oh, if you weren't paying attention, I bet you are now. So instead of shading above or below the line on an absolute value graph, you're going to shade inside or outside. So last one here. What would this one be? Same graph, absolute value. It's a V-shaped graph, but now I'm going up 3. So step 1, if you know the normal graph, right, I'm just going to go up 3. So at 0, I'm actually going to be up here at 3. And if you know that parent graph, it makes life so much easier. Oh no, look what happened. I made a solid line, but it should be a dotted line. So this is why I always use pencil, so I can erase. And now, am I shading out here or am I shading in here? I'm going to pick 0, 0. If it works, I'm going to shade out here. If it doesn't work, I'm going to shade in here. 0 is less than 0 plus 3. Is 0 less than 3? Yes. So that means I'm shading outside this graph. So you really need to shade all of it. I'm going to shade in smiley faces. All of this out here. All of this works. So everything other than what's inside the V graph works. We'll practice more in class.